Welcome to Butu Academy, Lessons that Empower. Now on this lesson, we are going to be looking at momentum and impulse, one of the topics that we find in Physical Sciences, paper 1. Okay, before we go into the contents of the lesson, let us first look at an extract from the exam guidelines in grade 12. So the first thing that we need to know according to our exam guideline is the definition of momentum. And as you can see, it is defined as a product of an object's mass and velocity. That is the definition according to the exam guideline, and that's exactly what you write when you are asked about momentum, the definition of momentum. The second bullet point says we should be able to describe linear momentum as a vector quantity, and we all know what it means. It means that it has a magnitude and direction. Now in this case, our momentum must take the same direction as the velocity, as we can see that momentum is a product of mass and velocity. So momentum as a vector quantity will have a direction, and that would be the same direction as the velocity, right? Then bullet number 3 says we should be able to calculate momentum of a moving object using the formula P is equals to mv, as you can see there. Okay, now we'll go straight into the first 3 bullet points. We've already dealt with the definition. We've already spoken about the vector quantity, that is momentum. Now let us look at some of the other things that we need to know. Okay, we've already dealt with the definition. Now the formula that we're going to be using to calculate momentum is this one. P is equals to m times v, where P is the momentum of the object in kilogram meters per second, and m is the mass of the object in kilograms, and v is the velocity of the object in meters per second. And that would make sense because momentum is in kilogram meters per second. That would mean these are the units that are coming from the mass, and these are the units that are coming from the velocity. Okay, now momentum is a vector quantity. We've already mentioned that. Therefore, it has both magnitude and direction. The direction of the momentum is always the same as the direction of the velocity. This is just a recap of what we've seen in the exam guideline. Okay, so the momentum of an object can be changed by changing its velocity or its mass, or both velocity and mass. Most of the time in our curriculum, you'll find a situation where the mass remains the same, but the velocity changes. It means you'll have 2 velocities, one being the initial velocity and the other one being the final velocity. Now from what we've learned here, we should be able to do one worked example. Let us get straight into it. Okay, so in our worked example here, we have a truck of mass 180 kilograms. Obviously this would be the mass. It's traveling to the east, and this is the direction, obviously, and at the speed of 6.5 meters per second. That means that is our v. The question says calculate the momentum of the object. Obviously, we've just learned from the previous slide that momentum P is equals to m multiplied by v. Okay, so we're then going to substitute and say, okay, the mass is 1,800 multiplied by 6.5, and we get our answer. Let's go to the calculator. So that will be 1,800 multiplied by 6.5, and get our answer 11,700. So that the answer would be 11,700 kilograms meters per second. These are the units for momentum. Remember, momentum is a vector quantity. We've just been told there that this is moving to the east. Therefore, the momentum of the object is also to the east, as we know that the momentum of an object must be in the same direction as the velocity of the object. All right.